line.
Oh, that you might just buy another. Would you rather have better than nothing? Better than nothing. Imagine all of us on one guy.
What is it better than Lenovo though? Exactly, bro. Pick your poison. Pick your poison, Michael.
Honestly, I have a Lenovo, so I'm just going with it.
You have a Lenovo?
I'd rather run with my crap.
I thought so highly of you until you told me that. No,
Yeah, I was actually starting to be like, but it's alien layer. Why?
I made that completely up.
Oh.
I thought they were gonna
Did
get
you
us
not
scared.
realize
went
that
on
when he
this
just
rant about something.
All right.
he slipped it in the wrong.
I didn't make up the part about computer lab, but I didn't make. I don't know what. All right. All right, here we go. Let's get rolling here. Questions on the homework.
Talking about that 380 guy though.
All right. All right. As long as everyone is quiet, we can do that. All right. Really, number 8 was the one?
Yes, I could not figure it out.
I'm assuming it's because you don't know how to read a clock.
That's probably most likely.
Okay, so it says the hands of the clock. So not to insult your intelligence too much, but you got a big hand points to hours. I'm sorry, big hand points to minutes. You got a little hand that points to hours. So you got long and you got short back on the clock. All right, so number 8, it says the hands, plural, of the clock form a 120-degree angle at some o'clock and some o'clock. So the hands of the clock. I understand why you didn't get this one, because there's lots of possibilities here.
Yeah.
This is a poorly written question. I gotta not give you this next year. So there's lots of possible answers. First off, let's figure out what's 120 degrees on a clock.
It's 30.
Each number we figured out yesterday was what, 30 degrees?
Yeah.
So that's going to mean that there's how many numbers difference between the two if it's 30 degrees per number? We got to get to 120. So it's going to be 4. So just give me a, anything that gives you 4. Like one could be on the 12. If the big hand's on the 12 and the small ones, if we count by 30s, like big hand's on the 12. Little hand would be on, if it was on the 1, that would be 30 degrees. If it was on the 2, it would be 60. If it was on the 3, it wouldn't be 120, it would be 90. But if it was on the 4, so 12 and 4 could be a possibility. As I see the answer in the book, they are claiming that it's just the big hand. The big hand is on the 12, and they're talking about the little hand. So there's actually 2 possibilities if the big hand is on the 12. They leave that part out. If the big hand is on the 12, the little hand for 120 degrees could either be on the 4 or on the 8. And that's what the book says the 2 answers are.
I said 84, let's go. Oh
but it's a poorly written question.
I brain
Yeah, but that's only 90 degrees.
I literally said, I'm cut from
It'd be 30, 69.
I'm cut from
All right.
I mean, it works.
All right. Any other questions?
I mean, it's true.
All right,
Like if you
here we go.
1 to 9, it is 1.
By the way, hopefully Chandler and Micah and Seth didn't keep the information from you yesterday when we figured it out.
I mean, I told Ethan.
So you told Ethan I was doing first.
Supposed to be the
All right.
I got pen on me.
So listen up. The way that the table, I couldn't even solve one of them. Way we finally figured out the table. Now we figured out 10. It was 11 we couldn't figure out.
I figured out something.
The way we figured out 11 was the fact that there were radii involved. All radii are congruent. Therefore, you get an isosceles triangle. And that was the key bit of information that we couldn't figure out in class.
Yeah, no, I realized it's just a simple little thing. If you take your number, your third number, I forgot which one it's called, but
Seth.
and divide it by 2. And
Seth figured out that there's a pattern involved. I'm going to ask you to recall that pattern in, I think it's next week when we have the class.
Okay.
But that pattern will be something that we will explore in a couple days from now. All right. Here we go. Number 1 is 85. Number 2 is 80. Number 3 is 150. Number 4 is 50.
What was it?
150. Number 5 is 52. And number 6 is 55. Yeah, apparently I like 5s. Number 7 is 30. We just talked about 8. It's 4 and 8. Don't worry if you missed 8. That's a poorly written question.
Number 9.
Well, I got to look at your picture, but B is no. All right, 10. I'm going to call this out on your table. I don't know how you wrote it, but I'm going to call it from top to bottom, left to right. Top to bottom, left to right. So it should be 60, 30, 70, 35, 56, 28, 50, 50. And the last one, I kind of let you guys astray. I didn't look at the picture very closely of what they were asking. If you put, what did we say yesterday the answer was? Yeah, 180 minus X, that would be true. However, I misinterpreted where the 2 was. And if you look at it, it's very poorly drawn as well. So this is, it's drawn like this. It's no doubt where 1 is, but they put 2 literally right here. So is 2 pointing to right or pointing to left? When I gave you the answer, I was assuming that 2 was right here because it kind of looks like it's a little bit closer. It turns out, because I can see the answers in the book, it's actually this angle.
That's why everything's wrong.
So I'm gonna just stop on number 11 and not call out the answers. If you figured out for 2, then yeah, we were good. We figured it out. The 2 is actually right here. All right. And the only reason I mean, that one is just weird. Right. Okay. That was it.
Weird.
All right. I gave you the warning at the start of the chapter. This is a whole chapter of definitions, and eventually it ramps up very severely. Today's that day. So today it's going to ramp up. We're going to get more vocabulary. We're going to get a couple new skills. The skills will be in form of a couple of theorems. So we're going to do some proofs. And I know, fortunately or unfortunate to you, the way that the course is designed is that I teach the theorem. Listen, please. Listen, please. Hey,
I slipped, bro.
I teach the theorems, and the theorems lead to applications. Hey, please stop talking, Dave. So I'm going to spend some time proving the theorems because that's what geometry is all about. And then I will take a pause and I will point out what the skill is. There's no hard formulas or anything like that, but it's a skill involved. You're going to look at a shape. You're going to say, oh, look, it's this particular construction. Therefore, I can make these conclusions. I think there's 3 theorems today. None of them are hard. They're actually pretty easy to prove after I show you the first one. The other ones kind of fall right in place. We're going to take a review because we need to absolutely do a review before we take the quiz. There's just too much stuff. You're going to get 3 new skills today, plus the skill we had from yesterday. That's a lot. The only nice thing is that 9.1, 9.2, 9.3 were just a whole lot of definitions. Until we got to yesterday, we didn't really get a skill. Yesterday was the first one, central angle and arcs. Or wait, 9.3 was central angle, 9.4 was arcs. Okay, but 9.1 and 9.2 were just pretty much just definitions that we will use throughout the chapter. So we'll do a review sheet tomorrow in class, and the review sheet will be a duplicate of the quiz, except I'll just give you more. I'll give you 6 examples of each one, and then on the quiz it'll be 1 or 2 per example. Okay. All right. Here's your homework. All of these or many of these require thought in order to get to the answer. At the end of class, we'll pull up some of the questions, maybe not for homework, but for the classroom exercises, and we'll look over how they formulate the questions. It does stink up the room, doesn't it? All right, so 3 theorems, and from each one of those theorems we get a skill, not a formula, but we get a skill. And I'll talk about those skills as we do each theorem. All right, here we go. Arcs, and well, we haven't seen chords since day 1, right? So arcs we got yesterday, major, minor, semi. Chords we had 9.1. We just said, hey, it's just a line that connects 2 points on a circle, or sorry, a segment that connects 2 points on a circle. Okay, here we go. Danny, look at the picture and tell me anything you see on the picture. What do you see, Danny?
I see it's dot.
Okay, there's no such thing as a dot in geometry. What do you see? Give me anything you see on this shape. I need you to use geometry words.
Quarter of a circle.
Okay, none of those except for the word circle is a geometry word. From this chapter, we've had lots of vocabulary. Look at the picture and tell me anything that you see. And it's got to be geometry, though. It can't be just random words. I see point T, so do you. Tell me something else you see. That's not an R. Tell me what you see, geometry. Yes, you do. You know plenty of things in geometry. Give me any word that you know from the geometry book. Any word. Circle. What's the name of that circle? Okay, what do we learn? Section 9.1. Circles are all named by their This is circle T, yes? Danny, you can pay attention and get this. But it doesn't involve drawing pictures. It doesn't involve looking at your desk while I'm teaching. It involves paying attention. But I'm telling you, you can do this. It's circle O. That's the symbol for circle. Matt, tell me anything on that you see.
Arc RS.
I see arc RS. Is it a major or minor? Minor arc RS. Wes, give me something you see that we haven't already said.
Diameter.
There's no diameter depicted. There is, all circles have a diameter, it's just not depicted. What do you see?
So then what would RS be?
Oh, we'll get to that.
Yeah, because I was going to say RS is a chord.
RS is a chord, so you see chord RS. Good. Anything we left off? We got chord RS, we got minor arc RS. What else?
Would it be a major arc?
Which one is a major arc?
Like from arc. Yeah.
RTS, major arc RTS. Anything we left off? We said, Danny said finally circle O. We got chord RS. We got minor arc RS. We got major arc RTS. Anything left? No, that's it. Now you could say points TRS and O, but that's everything on this thing. So that's a quick review of what we've done. Remember, this is not the arc symbol, but it's like it. All right. Further, we had some definition that we've been using the last couple days. If you have a circle, the center, and you have an angle formed where the vertex is the center, we call that angle. What do we call it?
Central angle.
Central angle. Okay. And then lastly, we have arcs, right? And the relationship between arcs and central angles they're the same thing, right? The arc and the central angle are exactly the same. We call that the measure of the arc. Yesterday I made a big deal of saying, hey, confusing name. You're like, what's confusing? It's the measure. Because we're going to get arc length here in a little bit. And the word length and measure kind of flip-flop in your head. You're like, which one is the degree? Which one is the measurement? I even use the word measurement, and that's not what this is. It's the angle measurement. So the rest of the chapter, I mean, it's a lot of stuff, and it's going to come at you really quick. It's going to hit you in the face, right? All right. So we're going to start off with a proof. So here's where you turn your brain on. You look at the proof. We're going to do the proof real quick. It's going to be a theorem, and we're going to get a skill from this. Well, let's look at the picture. What are we given? We are given that it's circle O, and that arc RS, they're depicted here in red. Arc RS is congruent to arc TU. Did everybody see that?
Yes.
I'm going to prove that TU and RS, which are what? They're both what? They're both chords, and those two chords are congruent to each other. Seems a pretty crazy claim. Ends up being a pretty easy thing to prove once I show you a little trick. Are you ready? Here's the trick. I'm going to connect R. I'm going to connect T. I'm going to connect U and S. In other words, what am I making? I'm making a whole bunch of
Chords.
not chords. You said connect T to O, R to O. I'm making a whole bunch of radii. So I get that picture. Now be careful. I'm going to label 1 and 2 here. These are not vertical, right? Because it doesn't go from R to U in a straight line. So 1 and 2 are not vertical, but it did make a whole bunch of radii. And that's just basic construction. Matt, what do you know about radii?
They are all the same length on the circle.
So therefore, I can immediately claim
That those are all congruent.
I'm trying to show that TU is congruent to RS. Notice both of those are part of and part of, by what I just drew, 2 triangles. So we're back to our standard high school proof, which is show what? Show the 2 triangles are congruent and then call out our friend. That's what we're going to do. Okay, you just showed, I'm penless, showed that congruent. So I got an S and an S. I said that 1 and 2 are not vertical. They kind of look like they are, but they're not. What else do we need? We either need that side, well, that would be, well, we would be done at that point, or we need to prove that 1 is congruent to 2. They're not vertical. If they were, we would be done. Turns out 1 is congruent to 2. Anybody know why? Yesterday's class. Why is 1 congruent to 2?
Central angle.
Central angle. What do we know about central angles?
It's an angle.
No, they're not all the same. One could be 10, one could be 20.
Angle in a circle that has its vertex is at the center of the circle.
So 1 and 2 are both central angles.
They both meet up and like all their lines are congruent.
What arc do those?
Arcs in the same or congruent circles have equal measurements.
So we are told that the 2 arcs are already congruent. Therefore, if the arcs are congruent, what do you know about the central angles?
They're congruent.
They're congruent. So this is theorem, what is it? 9, 2, 3? Postulate 16? Okay. So by postulate 16, I couldn't remember that. But I said what Matt said. Right? So this is postulate 16. Okay. Now you just showed 1's congruent to 2, so are the triangles congruent?
Yes.
Why?
SAS.
And you're done. It was pretty simple. The trick was we made radii. It'll be the trick every time. Yes.
So since 1 and 2 are actually vertical angles,
They're not.
they're not. What makes them not vertical angles?
Well, I wish the book would have drawn a little bit. So let's consider this arc and this arc, right? Now, when you draw that, you can see that you don't have vertical angles, right? So this would have been a much better drawing than what they drew, because it's certainly, any high school student looks at this, they're going to claim vertical angles. It's really not. Could they be vertical angles? Sure, if you shift them around like this, they will turn vertical angles. But we're saying for all cases, as long as the arcs are congruent, then the central angles are congruent, and then all these are radii, you got SAS. All right. So this is theorem 9.4, and it says the following. It's also biconditional. I wish they would have written it as an if and only if they didn't. So if you have 2 arcs on the same circle, or congruent circles that are congruent, then the chords that connect the 2 endpoints of the arcs are congruent. That's what this first statement says. And then the converse to that is true. And the converse is that if the chords are congruent, then the arcs have to be congruent. So this is a biconditional. It's an if and only if. They just chose not to write it as an if and only if.
Yeah, I know you can't do it that way. You have to do it.
All right, what skill do we, I said we're gonna get a skill from each one of the 3. Here's the skill. Let's say, give me a reasonable arc measure here, or measure that arc. Let's say that arc is 80 degrees, and this arc is 80 degrees, and this chord is 10 centimeters. You ready for the skill? How long is RS? All right, there's your skill. right? And any other combination of each. Well, let's say this is 10 centimeters, and I erase that. Therefore, how big is arc TU? That's the skill. It's not a very complicated skill, but that's the skill. We okay with that? Pretty easy, right? No formula. We will get formulas, not today, but we'll eventually get to some formulas tomorrow. No, tomorrow we're doing a review, so it'll be tomorrow's Wednesday, Thursday. We'll get to our first formula. All right. Couple quick definitions. You can put this in your book of truth. It's up to you or not. It's a pretty simple definition. If y is on arc xz and the distance of xy is the same as yz, guess what we call point y? Duh, right? If xy is congruent to yz, then y's got to be a midpoint. It does have one extra statement here. It says that if there is any line, ray, or segment that intersects y, then we say that it's a bisector of the arc. Okay, that's kind of self-obvious as well, too. Now notice, it says bisects XYZ, right? I put 3 letters, even though it's a minor arc. It could be a major or a minor arc. Clearly, this one's a minor arc. And yesterday I said that major arcs must use 3 letters. Minor arcs, I don't think you're ever going to see any book that uses 3 letters, but you could. I mean, there would be no confusion. All right, so that's a pretty easy definition. Midpoint. We good? Any good?
Yeah.
Okay. All right. I said 3 proofs. Number 2. So here's the construction. You got circle O. You got in this case, you got a diameter, right? And then you have a chord. It's not a diameter. And the relationship between the two, well, remember, diameter is a chord. Between the 2 chords is they're perpendicular to each other. Yeah? So it turns out we're going to try to prove 2 things. One, that it bisects the chord, the diameter bisects the chord. And the second thing is it also bisects the arc AB, meaning that we get AD, DB are congruent to each other. Okay? Well, that's what we're trying to prove. But certainly AB doesn't bisect CD, right? Right. Okay, so that's our, we got to prove 2 things. We're going to use that same trick that we just did. I'm going to make a radii. So O to A, O to B, make some radii. Okay, since they are radii, I'm going to label this angle 1 and angle 2. Okay, what do we know about OA and OB now? They're congruent. I also know that these are right angles right here. Why? Because they're perpendicular, right? So definition of perpendicular. Let me catch up. Oh boy, I'm doing this out of order. But OZ is congruent to OZ because. And why did I just do all of that? Yeah, but why did I do all that? Because for this particular case, what did I just prove? Look at the triangles and why are they congruent? No, I didn't do SSS. I didn't do SAS either. Is it a right triangle?
Yes.
Is it HL? What does HL mean, Matt? Do we have on each triangle a hypotenuse and a leg congruent?
Yes.
Therefore, it's HL. Okay. As soon as you see a right triangle, I'm not saying, you know, it's always HL, but as soon as you see a right triangle, HL is the easiest one. By the way, HL is the ASS. We just don't say ASS because that wouldn't be nice. All right. We're not done because we got to prove that AZ is congruent to BC. Well, what's going to be my next statement? Yeah. But I also made one extra step, so we're halfway there, right? I just proved AZ, BZ. I also said that 1 is congruent to 2 also by CPC. True? Because CPCTC, corresponding parts, congruent triangles are congruent. Why did I just say that 1 is congruent to 2? What's that going to give me? Do you see it? Angle 1 makes arc AD. Angle 2 makes arc DB. And if you just said that 1 is congruent to 2 by postulate 16, therefore, and that was my second part, and we're done. Cool? All right. They love this one. You're going to see this one a lot. How do you visually identify this one? What was our original construction? What did it look like at the start? It looked like that. You got what two things?
Bisector and.
Yeah, but you don't know what's a bisector. That's what the theorem says. You have a, could be a radius as well too, but you either got a radius or diameter and you have a, and the relationship between those two are, and if that's the case, then the radius diameter bisects the chord and creates two congruent arcs. That's theorem. What are we on? 9, what? 5? That's theorem 9.5. Two things. Oops, sorry. If this is what it visually looks like, for me, I see that chord and I see perpendicular. I'm like, oh, okay, got it. If you see that chord, you see that it's going to be a radius or a diameter. But as soon as you see that perpendicular thing right there, because remember, the chord does not have to be perpendicular. If I make point E right here, and I connect A to E, are they perpendicular? Right. So this is only if they are perpendicular. And tonight for homework, you're going to see they just love this one right here. But there's two things. Dan, you got it written down? Connor, yay? You understand it? We'll get to the understanding here in a second. I'll show you what the questions will look like. Ethan, give me a number.
30.
Connor, AZ is 30. This is the picture. How big is ZB? That's the skill. That's half of the skill. Give me a acute angle. Yeah. What? No, give me any, just make it up. Give me acute angle. A number that's acute.
Oh, gosh, 80.
If dB is 80, how big is AD?
80.
There's your skill. Not very impressive, right? It will be impressive. You're gonna get 3 of these. This is a second of 3. We're gonna get the third one, and they're gonna combine all 3 into like one question. But you weren't impressed by the first one. You're not impressed by this one, right? Yet I will have kids miss this question, literally. That'll be construction. I'll say AZ is 10, and I'll say, how big is AB? How big is AB? Somehow people lose their brains and they can't do this. Now, granted, we got a whole chapter ahead of us, so this is one of many, many, many things. But yeah, you just showed me that you all understand this, and it's pretty easy. All right, so here's an example. Look at how complicated that picture is.
It's because they twisted it in the direction.
They're combining the previous one, chord, arc, right? They're combining the previous one with what we just did. So it's like, it's a twofer, right? All right, Chris, pick one. You want to do the chord or you want to do the perpendicular chord? Either one. Okay, let's do the chord. So go back to the first theorem that we had today. The first theorem said that if you have a chord, 10, and if you have any other chord, I'll draw another one, that's also 10. What can you tell me about this arc that I just made? It's equal to the other one. Okay. Now I'll erase that. Do we have any other chord up there that's 10? Well, that's a good assumption, but you got to prove it. Anybody?
Well, we have to is 5.
Ooh, so we can use the one that we just did, which says that if you have what construction? Yeah, but I'm saying what's the visual construction? Okay, you're going to claim that I get you, that that's 5. Great. But what does the construction have to visibly be? You got to have two things. I got to have radius and diameter and a visually eyeball goes where? What was the theorem 9 what? 9.5. I got my radius diameter right here. What was the other thing I need? What? That's the result of this. It is a bisector, which is, by the way, why we're going to be able to claim that x is 5. But visually, you have to have something. Okay, I'll draw you the thing that it's not. Right? Here's a diameter, right? Here's a chord. Is this angle perpendicular? Is that angle perpendicular? That's what you got to have. You visually have to have, it's a lot of mess here, but you got to have a radius diameter and you got to have a perpendicular chord. If you have that, you can claim 9.5. What's 9.5 say? Right, diameter is perpendicular to chord. Okay, so therefore x is okay. 10. What's this chord? So if this is 86, there you go. So how big's y?
43.
There you go. That's a lot of work, right? So tonight for homework, they're going to combine 3. And how many did we just do? We did those, right? So we've done 2 out of 3. You ready for the last one? Oh, question on this? All right, here we go. By the way, here is everything that Chris just said, right? He goes, by theorem 9.5, therefore if that's 5, that's 5. Therefore the whole thing is 10. Therefore by the previous theorem 9.4, then if that's 10 and that's 10, if this is 86, that's 80. Oh, I'm out of breath here. If the whole thing's 86, then half of it was 43.
That was a lot.
Did I not say that was going to happen?
Well, I didn't expect like 10,000 people to come in here.
I didn't even notice they were there. I just turned my head and I see like a crowd of people behind me. I was like,
I
oh
thought there was
god.
gonna be just a couple people coming in, but no, they had to pick up the whole back.
You did fine. All right.
I didn't even notice.
Okay.
It's like, what just happened?
That's why I picked Matt as the grader, because I knew Seth wouldn't pay attention. All right. Okay, so they're going to also give you this in the form of words or whatever. You're going to take all these words and draw a nice, pretty picture. So it says, find the length of a chord that's 5 from the center. It doesn't say any units. You know, sometimes in geometry they get lazy. They don't put units. So it's 5 units from the center, which has a radius of 8. Find the length of a chord that's 5 from the center, and the radius is 8. Well, where's the radius? So we need 1 or 2.
Would you need to create another radius?
I would. So where do you want me to put it?
Like just across from
O to A or O to B, either one of those. It doesn't matter. I do both of them. You only need 1. I heard Micah already discussing this one. Not this particular one, but one in the book like this.
Yeah.
And he was like, well, how in the world do I ever solve this? We're going to Pythagorean theorem this sucker.
Oh no.
Yeah, right? How long? Oh, by the way, when we Pythagorean theorem this sucker, we don't get the answer. We get half of the answer because you'd only be solving for AP. So if that's my x,
Wouldn't that just roll over to the other side?
it would, but I'm saying, so you get half of it, so you'd have to just double your answer to get to the final thing. Okay, so how big is x? Well, so that leg or hypotenuse? So 64 minus, which is 64 minus 25? 39. Take the square root of 39 or any perfect squares in that. Therefore, x is square root of 39. So how long is AB? Double it.
Square root.
Oops, there you go. Okay, that's pretty cool.
It's not a cool answer.
Last one.
Not very.
Here we go.
of you.
Hey, what's the difference between this one and the previous one?
Nada.
See, this would be wonderful. if-
We have not one chord, we have two chords. Notice two chords, but it kind of looks like the previous one had a diameter. Okay, I said it could be a radius or a diameter. Okay, we still have the two chords, we still have the perpendicular. So this is just double fun, right? Looks like we're trying to prove that OQ, this piece, I'm sorry, we're trying to prove that this piece, the two chords are congruent to each other. We are given that this piece and that piece are congruent. So OQ and OP are congruent. All right, now here's the setup. So what's the trick? Again, third time. We're just going to make how many radii? 2 or 4? We're going to make 4 radii. 1, 2, 3, 4. But all those red lines are, there's 4 triangles, and every one of those red lines is a radii, therefore every one of those red lines is congruent. Therefore, I already had this piece, and if all of those are congruent, and what kind of triangle are those?
Right.
Therefore, all of those triangles we just made are congruent by HL. Ooh, I got to catch up.
Pretty butterfly in a circle.
What?
I see it. It's beautiful.
Yes, it is a butterfly, isn't it? All right. Great. Okay, so I'll finish it up real quick here. If all the triangles are congruent, then what do you know about TQ, QU, SP, and RP? They're all congruent to each other. And if they're all congruent to each other, what's this piece plus this piece compared to this piece plus this piece? They're the same thing. Now, mathematically, I would have to say this, that TU would be this piece plus this piece. RS would be this piece plus this piece. But since they're all the same, it's like saying 2, 2, 2, 2. Well, 2 plus 2 equals 2 plus 2. You follow the logic? Okay. Therefore, we're done. QED.
I mean, I don't know.
By the way, we got to go back to the picture, Chandler. We got to go back to the picture to see what the heck we had to start with. That's what we have to start with. So, Matt, what do we have to start with?
That.
Yeah, but describe it.
A circle with lines inside of it that you don't understand.
Better than that.
A circle with chords.
Crazy fun.
I have a circle with how many chords?
2 chords.
And we have how many radii?
0 right now. 2.
I'm sorry, how many perpendiculars that come from the center?
2.
2. Now we can make it a radii by going like that, but it has to be, you have to be given that this piece is congruent to this piece. So we have circle, 2 chords, perpendiculars from the center, and that these 2 little pieces right here are congruent. If you have this shape, what can you conclude?
Yes, that's
That the 2 chords are congruent. All right, you got to write that down.
Oh, I already wrote that down.
And it is biconditional, goes both ways. If the chords are congruent, these pieces are congruent. If these are congruent, then the chords are congruent. And you also have to have that perpendicular part in there as well, too. It would not work if I drew that. It's got to be perpendicular. It's not that it's just it's 2 chords, it's 2 chords that are perpendicular to the lines that are drawn from the center. Once again, no formula from this, it's just a statement. Oh, Chris, good job answering that question too. I know I put you on the spot there, but that was good. Because that was a multiple step one and you figured it out.
9? Okay. It is a whole bunch of stuff.
Keep quiet, keep quiet. I mean, do it, but softly.
So, the closest I got was my guy who was engineering the answer to that.
Your definition of quiet is not my definition.
This is my quiet.
Don't ever be a criminal. It's right next to us. Quiet.
I'm gonna go with it.
Okay, says Seth. Yeah.
Remember, this is a stealth mission.
All right, we good?
No.
All right. So what is this skill? What is this going to look like? They're going to say something like this piece is 6 centimeters. TU is 10 centimeters. They'll say that RS is also 10 centimeters, and they'll say how big is RP. I'm sorry, OP. 6.
Oh my
Wait, you guys didn't know that you got the phone?
Oh my word! Why did I say you guys could do that?
Okay. We
In
got
my mind, I thought you would be able to do that quietly. Clearly, I
it.
mean,
Everybody's gonna walk.
Have you met them?
Yeah.
well, there's a chance. All right.
Seth can be quiet a little bit.
So here we go. Hey, this is kind of what Chris did. Cadence, you're up.
What?
What's the shape you generally see? Was this the first, second, or third theorem of today? This is the third theorem. All right. The third theorem says if this is congruent to this, okay, we immediately don't know that because it doesn't say what that is. But it does say that this is 6.
Oh, wait, so would X be 2?
How would it be 2 if it?
Okay.
Because
Now,
3 is half of 6. So
I want you to ignore this and just look at that construction. That looks like first, second, or third theorem. And what did the second theorem say?
a diameter that's
That if you got that,
to a chord bisects a chord.
so therefore, how big is ST?
6.
Uh-uh.
Wait, 3.
3. So that was the second theorem. Now, how long is RT?
6.
How long is UT? Now it looks like the third theorem, and the third theorem says if that's 6 and that's 6, then what do you know about these two? Therefore, it's there's one way they could ask that question. Okay. So we used 2 of the theorems. I mean, I'm sure for homework there's one they probably use all 3 of the theorems we learned today, but most of them you'll have to use at least 2.
Yeah.
You're gonna have to visually look and see what's the construction. It's in terms of, is this really, really complicated? No, it's not really complicated, but it's enough stuff that will get you confused if you didn't pay attention today.
Danny.
All right. All right. Well, let's see. Oh, by the way, good job, James. Let's look at this one right here, Danny, number 4. Okay. As you look at this picture, right? Just ignore all that. Just right here. Does this look like the first, second, or third theorem that we did today? It looks like the third if it looks like this. We have 2 chords perpendicular. First, second, or third? It kind of looks like the second one. The big picture, the second one says that if you have something that comes from the center that goes through a chord and it's perpendicular, that's what we got. That it says what? I mean, look at your second theorem. That if you have that construction, we do, then what? Uh-huh. Remember the conversation we had to start? All right. Here's what it says. It says that this chord and this chord are congruent. I'm sorry, this arc and this arc are congruent, and this chord is bisected. So now let's plug in some numbers. It says that AB is 16. So therefore, this piece would be, if the whole thing is 16, then this piece would be 8, and that would be 8. Okay, good. That's not what this one is asking, but we got a little bit going. So we know that this is 8, and this is 8. Okay. It says that OM is 16. Why did I say 8? No, we're right, because
No,
AB is
OM
16, so it is
is
8. I'm right.
OM is 6.
Not 16.
That's the mistake. Thank you. Okay, so That's a construction. It's asking us to find the radius. Where on the picture is the radius, Danny? Where's the radius depicted on that? What? What's a radius? No, that's the circumference. Where's the radius? The radius goes from the center out. So where's the radius on our picture? Okay, OM is not a radius because it doesn't go all the way down. If it went all the way down, it would be a radius. It would be OB or OA. So since you said OB first, that's what they want us to find. Notice that is now part of one triangle where this part was 6, this part was 8. It was a right triangle. We're trying to find that. What are you going to do to solve that? What technique do you have to solve that? If you have a right triangle and you know 2 of the sides, you could always use Pythagorean theorem, which says what, Benny? So what's a squared? Which one is a? 6 squared is 36. You talking? 64. Then what? Okay, so you get 36 plus 64 is equal to x squared. Now what? That's 100. Last step. We never divide to get rid of squaring. It's always the last step on every single Pythagorean theorem problem. How do we get rid of squaring? The inverse of squaring is? The inverse of addition is subtraction. The inverse of multiplication is division. What's the inverse of squaring? Square rooting. So we take the square root of both sides. Square root of x squared. The square root and squaring get rid of each other. They cancel each other out. And you're left with x. And the square root of 100 is. And you're done. Okay. So multiple steps, including steps from the previous chapter, Pythagorean theorem. But most of these start off with, which theorem do we think apply? You go from the picture. Matt, you want that one?
I'll do that.
All right. Tell me what you're thinking.
All right, so. Wait a second, if the radius is 13, OM's 13.
No,
Why not?
because OM doesn't go all the way to the edge.
What do you mean?
Is it like 12? It's not all the way.
It's a good guess.
Why not? It was funny because like he just like
Oh,
he was-
why not?
He
I
was so
don't have my
confident.
glasses on. Why not?
All right. I believe this is Pythagorean theorem. If PQ is 10, the PM is,
Wait.
PQ is 10, the PM is, okay. So you get a triangle that looks like 5, 13, Pythagorean theorem.
Oh my god, you were smarty.
Well,
All right, e-learners, any questions? Anybody live? Nope. If you have any questions, send me a chat.
Sorry, I'm
Or
blind.
email.
I didn't see that.
Yeah, you need glasses.
I have